sounds tight tonight.
Internet smiles on us.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I am Tom Nardi.
This is episode 217, the Unintentional Space and 3D Printing episode. This week in the news, I'd like to start off by mentioning again the second round of the Hackaday Prize Assistive Tech round. And I actually just wanted to mention this because last week I was thinking about Tom's write-up, actually, of the announcement for it. And one thing that I thought you did really well was to pick up on a couple, assistive tech hacks that weren't necessarily, obviously medical, but they improved the quality of life of people who have problems. In this case, it was a radio for people's parents who were suffering from dementia, but it can be, older people get nearsighted and they need bigger buttons, or, all sorts of things are complicated. There must be a million ways you can help people who have trouble with tech deal with tech. I remember an old friend of mine used to have a Kindle, and he had limited mobility with his hands. And when they got rid of the buttons on the side of the Kindle that would advance page forward, that was an absolute killer for him, because flipping the pages on books was already bad enough. And then he got this Kindle with these nice big buttons on the side, and that was like a godsend to him. And then they got rid of it and replaced it with this horrible touchscreen that was all wiggly and fidgety, as touchscreens tend to be. He and a friend of his worked on hacking it to add buttons back to his Kindle again. And that was a pretty sweet hack. So, there's all these kind of, not obviously medical hacks that'll help people out. And I just love those particularly clever kinds. And just wanted to highlight that again.
Anything that helps somebody just live and work and play and learn. I mean, it doesn't have to be a huge... There's one of the other projects, I don't know if I put it in that write-up, but it was a guitar tuner made for a blind user.
Oh, right.
Digital guitar tuner has a little screen, and that doesn't do you any good, right? So it was, it's something simple as that, that you don't realize, if you're blind and you enjoy playing guitar, how do you tune it other than just by ear, right? So there's all kinds of little... Like you said, stuff that you wouldn't necessarily think of at first. Well, we all think about, prosthetics and that sort of thing, but it could just be a little thing that just makes their life a little easier, a little better, and gives them some independence that they'd lost.
I think that's actually part of the reason I love this category so much, is because there are all of these coming out of left field kind of how to help people solutions that I wouldn't have thought of. And part of it's just the creativity in coming up with the problem and solving the problem, as well as, how you solve it. So anyway, hype for the Hackaday Prize and the Assistive Tech Round. And in other news, ESA, that's the European Space Agency's Jupiter-bound probe hits antenna snag. Take it away, space nerd Tom Nardi.
This is one of those stories where, we watch these launches now. Everybody's live streaming launches, and you kind of get this impression that, well, as long as it gets off the ground, it'll be fine, right? Once it's up there, it'll be cool. But that's only the beginning of a very hazardous journey that these probes and stuff have to go on. And in this case, ESA, they're sending a probe to Jupiter's moons, which incidentally won't arrive until 2030. So don't look for any results immediately. But, it got off the ground fine, and it was on its way out there, and it was in the checkout period where they start bringing the systems online and seeing what's what. And there's a 16-meter radar antenna that they commanded to open, and it just didn't. It went, went a little bit. It just jammed up, and they sent the command a couple times. It just keeps hitting the spot where it doesn't pass. There's actually a camera on board so they can see where it's jamming up. And the going theory right now, because of course nobody's up there to look at it, is that one of the little pins may have failed to retract fully, which means you could be talking about, a millimeter or two that's keeping this thing from moving through the track. Going off of that idea, what they're hoping to do is literally shake the craft. They're trying to do like engine burns, posing to kind of shake it back and forth to see if they can knock the pin out or push it whatever way it has to go. They're talking about rotating so that the sun hits it, alternating, so you get like a little heating, cooling action. Which if anybody's ever tried to get like a rusted bolt out knows, heating it up and cooling it off can free up through expansion and contraction. You can plan for a lot of things. You can plan for a software fault or some kind of module, and we've written plenty of posts about all the kind of like deep space hacks that have gotten these things working again. But it's real hard to plan for a pin that doesn't come out and come up with a B plan. So it's going to be interesting to see if they can get this free and what that looks like. But it is important to note that none of these craft go up with just one goal. So this one in particular has 10 primary instruments, of which this radar is only one of. So, of course it would be a bummer if it goes all the way to Jupiter and can't use this radar, because it's supposed to like look through the ice to see, what's in the ice of the Jupiter moons. It would be a big disappointment, but there would still be plenty of useful science return. So, it won't be the end of the world, but it would be not ideal.
Right. I love all of these kind of brute force solutions, like, shake the thing, see if you can heat it up.
Just shake it.
I mean, the problem is, of course, you'd want to like flip it over so that the thing falls out, but there is no up and down, right? Because you're in space, so that doesn't help much. Comments on this one are, of course, fantastic. People suggest flying near black holes. People suggest, my favorite actually is that someone forgot to unsnap the cloth belt that keeps it closed, like you have on the umbrellas, You have the little thing that you snap. Yeah, totally.
And we'll definitely check back with this, as they find out more. I am kind of curious because, at some point, when do you stop fiddling with it, right? Because, like I said, there are other instruments that work. So do you keep spinning the thing around and shaking it?
You don't want to use up all your gas.
Right. Or damage something else. Like, so there's got to be some kind of line in the sand where, like, listen, we tried to shake this thing for 3 days and it didn't work. Let's just, roll with what we got. So it'll be interesting to see if they can, free things up, or if they just, take their losses and keep moving.
This is a journey into sound.
What's that sound?
What's that sound?
All right, that brings us to What's That Sound? This week is a Guess the Sound week.
That's always a Guess the Sound week when I'm here.
So those of you at home, and Tom, have a listen to the sound and see if you can tell us what it is. I'll give you one hint.
Okay.
It's a household sound.
A household sound? Really? Not necessarily the modern household?
Not a modern household.
Not
exactly.
a modern household.
Yeah.
Is it like an old school washing machine thing?
Not a bad guess, but not right.
I know they had like the tub with the cylinders on it.
Totally. I actually was trying to listen for washing machine sounds this week and couldn't find any that didn't just sound like random, like white noise with motor noise in the background.
I don't know. It's before you had said household, I would almost thought some kind of like old manually operated like printing press or something that's like rolling over the little raised letters.
Right.
I don't know. I give up.
No worries. It is actually a...
Really? Wow. That is not what I would have thought at all.
There's that little like wheezing noise in there. If you go back and listen to it again, I'm sure you'll hear it. There's this little like wheezy noise in there that is maybe the giveaway.
Wow. I would really have bet anything that was like a roller, like a mechanical roller.
But I'm also willing to admit this one was evil difficult.
It's remarkably, and I think it's because it's so uniform. It's exactly the same sound. So like, It sounds like something making the same little 8-inch roll back and forth. So wow, that's a good one.
Sweet. Well, those of you out there, if you have a guess for what this is, head on over to hackaday.com/podcast. You'll find the form to fill out. Give us your best guess, your handle, and be entered in a drawing to win a Hackaday podcast t-shirt. My first hack this week, Kerf Meter measures laser cutter kerf allowances on the fly. Maybe it's not even really a hack. This is much more of a research project. And in fact, it's coming out of the Hasso-Plattner Institute, University of Potsdam, Patrick Bowdish's lab. I'm going to read out the students' names who worked on this project because it's just so rad. And that would be Shoei Katakura, Martin Taraz, Mohammed Abdullah, Paul Methfisel, Lucas Rambold, and Robert Kovacs, because all y'all deserve a shout out for the coolest hack I've seen in a long time. When you cut with a laser cutter or with a saw or anything, actually, some of the materials removed. This is the kerf, right? And the inside of your cut and the outside of your cut don't exactly line up. The problem with all of this is if you want to make like finger joints or something that fit together tightly but not too tight, you have to know how much extra material is removed in the kerf and then accommodate for that in your G code, right? You expand it up or shrink it a little bit accordingly. This is a really sweet machine design to measure automatically the kerf cut by a laser cutter. And what it does is it cuts out basically they call it a spiral gauge. It's kind of a spirally cam-shaped circle, and then they drill 2 holes in it, they insert some pins in those holes, and they try to turn it until it locks. And because it's a spiral, because it gets wider as it goes around, if you turn it against the spiral, eventually it sticks in the hole. And they use a DC motor driven with a given amount of torque, and then they measure the angle at which it sticks, and then they can back out the kerf width from this. And that alone is super duper clever. But what's awesome about this is that all the other ways to like measure a kerf in a laser cutting setup involve human participation. And this one can be entirely automated. This is like laser cutter cuts this pattern out, sticks its little prongy thing in there, turns it till it sticks. And then it knows how much the kerf is and can correct your model for it. And so it can do this whole step completely automatically. This being a research paper, they actually go through all of the existing literature on cutting kerf meters for laser cutters. And you should have a look. You know, you can try to make your finger pieces and then just increase the kerf until you get it right. That's kind of lame. You can make like a trapezoid and try to fit it in a hole. And if you calibrate that out right, you know, that can tell you where the kerf is. There's all these different methods they bring up. You could just try to measure the width of the hole with a camera, for instance. You could do it with a micrometer. But this way is the best they could figure out. They get so accurate that they are way exceeding the accuracy of any of the 3 laser cutters that they're testing this out on. And so they're testing it out on professional machines too. They're testing it out on a Trotec machine and a Universal machine, which are actually like literally professional laser cutters, and also on a Glowforge, which is kind of like high-end prosumer machines. And so these are machines that are fairly accurate, and they get their kerf measured down more accurately. And better yet, because the thing is based on its jamming torque, they can tell exactly what force they get at a bunch of different curves. And so they can set the machine up to make the fingers fit just a little bit tight, or a little bit tighter than that, or yet even tighter, using the actual like tight fittingness of a piece in the estimation of it. In case you think that's not crazy enough, they actually then go and get people. I think they surveyed 20-something students and asked them which of these different joints was too tight and not tight enough, and they quantified how tight is too tight in box finger joints. You should read the PDF paper here. It is so exhaustive. It's amazing.
It's a kerf tour de force, right?
You won't want to know anything else about laser cutter kerf.
It's funny when I was editing this post before it went out. It's just like kerf, 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 kerf. Like every other sentence had kerf in it. I actually had to take some kerfs out. There was too many kerfs in this article, and I actually was a little nervous because I don't think Dan actually explains what kerf is. It's just like kerf, 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 kerf. But yeah, it is a problem that if you ever cut anything, you will certainly be aware of. Even if you know the old school table saw or something, it doesn't have to be anything so futuristic. If you ever, that has to go somewhere, right? When you cut a piece of wood, the blade width has to go somewhere.
That's right.
It's interesting you mentioned optical because I think if I was tasked with this, that's probably what I would have came up with too. But this is.
Yeah.
I mean, you can't beat the physical measurement, right? Especially like you said with being able to detect the force and see how tight they get. All right, it's a research paper, so I suppose we can't hold it to, real world standards necessarily. I do wonder how, like, in a dusty shop environment, how well would it really work, if it was not in such controlled conditions. Because you would think if you're that sensitive, if you get a little dust inside the gap, but on the other hand, you could fix that with a burst of air too. So I mean, it's just another hurdle to maybe overcome.
One thing they suggest to overcome that actually is doing it 3 times or 4 times because their little circular feature is actually small enough that it's probably smaller than whatever you're already using to assess your curve. So it's no worries to like repeat it 3 times.
Yeah, it's remarkably small, and I like you're saying they're exceeding the capability of the laser anyway, because now the weak link is going to be how well you have all your optics aligned and that kind of stuff, and the spot size and even spot orientation.
While making objects with this, they discover that the kerf size varies fairly consistently across the bed. And so if you do the calibration over in this one corner, you'll get one kerf size, but if you do the calibration in an opposite corner, you might get a different size, or if you do it in the middle. And so they actually go and they map out different measured kerf sizes across the bed, and they propose that you could compensate for that if you wanted to, which is totally crazy. And then the last bit that I thought was really awesome to make this thing turn, so they make their little cam-shaped thing, and then they put 2 holes in it and drop 2 pins in and turn it. Those 2 holes, of course, are cut with some kerf, and so they don't fit the pins quite exactly. And so they actually compensate for this unknown extra kerf in the holes that they're using for their kerf figuring outing machine. Yeah.
Right.
You can tell they're like actually doing this. This is not a theory paper. This is people who are out there and they're like, that didn't fit quite as tight as we thought. What could the variables be? And they're like, they're slopping the pins. Okay, we can compensate that. And then they're like, this didn't work well. Wait, it worked well when it was in that corner. Okay, let's map out the whole bed and figure out how the curve varies across the bed. Yeah, they've got this down. It's very impressive. But again, I think the thing that's most promising about this is that it's a completely automatic procedure. And that means you don't have to think about it anymore, right? You can just run this routine. It figures out what the kerf is. It adds that to your model. Boom. Done.
It's kind of interesting. It sort of reminds me auto leveling on a 3D printer, especially that, the idea that you might have to take it at a couple different locations and come up with like a mesh, because you're going to have slight variations in the bed and like the gantry, and especially on a laser that changes the spot size, and obviously that changes like the kerf. But just like a lot of these 3D printer automatic leveling things are now moving over to like load sensors that physically touch the bed. After experimenting with like magnetic sensors, which have their own variability, this is like a similar solution that, maybe sometimes you just got to poke the thing, like you could try optical things, you could try magnetic things, but like none of them really are a replacement for just sticking your finger on it and poking it and seeing what works. Well, not to concern ourselves too much with failed or, potentially failed space missions, but I did think this was an interesting one to bring up. This is a paper out of Nature that talks about, why is it so hard to land on the moon, right? I mean, we did it in the 60s with both crewed and uncrewed landers, and it seemed to have gone pretty well, at least in our collective memory. So, why is it in 2023, when we all have supercomputers in our pockets and incredible sensors and optical, why do these landers keep going splat? And, part of that was because there was a recent Japanese commercial lander, if you weren't aware, went splat a few days ago on its attempt. And it just seems like it should be easier, right? So the article kind of goes into the challenges that are there, and it's not, all right, first of all, it's very far away. You don't have real-time control. There's enough of a delay that you have to let the machine do its own decision making to a degree. But you also have, the dust. There's low-lying dust over the surface of the moon. So as you get closer, you start getting weird sensor noise from optical sensors and radar sensors. There's limited GPS, for lack of a better word, right? There are orbiters around the moon, but there are not enough of them to give you that kind of three-dimensional position fix like we enjoy here on Earth. So you're kind of left to your own devices there too to figure out where exactly you are and your that kind of thing. So that it is a much more challenging environment than we might at first think, even with all the modern technology. And then the other part of that too is that we're trying to land smaller, lighter, cheaper devices on the moon, whereas getting there during the space race, I mean, that you were talking about, everything with the kitchen sink was going into these things, and there was no cost was not an object, especially when you had humans on it, right? Like everything was on the table, so these things were packed to the gills with the best we could afford. Now we're trying to do things a little bit more sustainably, and every lander that touches down on the moon can't be $100 billion worth of development hardware, right? You got to be able to land cheap stuff. So we're kind of in that phase where you're almost figuring out, like, you got to be this high the ride. What do you really need to land on the moon successfully? And then we kind of spin out from there because, we're looking at like the Artemis project, there's other international interest, and finally doing something with the moon and trying to do like a commercialized presence. We're going to need a cost-effective FedEx truck for the moon, for lack of a better, it has to be something that we could just get there every time, drop its thing off. We can't keep coming up with all these different ideas. There needs to be some kind of standardized lander platform that we know will get you there on time. And that's kind of where we're at now. And realistically, that involves cracking some eggs until we find out what that, minimum requirement is.
Yeah, I love this article because a lot of things are harder than you think. And you don't always know the ways in which they're harder than you think until you try it. But this is not one that I'm going to get to try. So at least I'm stoked to read about what the problems are from people who have experience with it. For instance, the dust problem I just hadn't thought of. I'm surprised that like a radar wouldn't work to give you a pretty good feeling for how far you are away from the surface. I mean, I'd be obviously afraid of kind of anything optical because, like you say, if you're firing rockets to like slow the thing down, it's kicking up dust all over the place. I wonder if they don't also have some problems with radar because of that. I don't know. This is one of those Hackaday moments, though. We got a comment in from Jake who says, I wrote the laser rangefinder software that's supposed to be helping Nova C make a soft landing in a few months. Needless to say, I'm nervous about lunar dust being kicked up in the path of the laser. So, yeah. Laser rangefinder, that might be
tricky. There's a Hack Chat candidate if I ever heard one, too.
Tell you
if you're listening, please contact us about doing a chat.
My other favorite comments are like, why don't you just use parachutes? And that one, the lack of an atmosphere makes the parachute option not so live. But, if you're used to landing things on the Earth, or if you've seen things land on Mars, of course, you might be thinking this. And this is something that only thing going to slow you down is rockets pointed in the other direction, and they're going to cause all sorts of trouble. My next hack, compressed air keeps screws moving through modular production system, is the fourth video coming from Christopher Helmke. This is a fantastic series and machine he's building here. He makes 3D prints and sells them, and he's trying to make things like bagging up screws and bolts to go along with it as easy as possible. And indeed, he's building out this incredible modular automatic production line for kind of small scale, hobbyist level production. And I think that's something that's going to be interesting to a lot of our listeners, a lot of Hackaday type people. You know, if you sell something in a 100-piece production run, you have to bag all 100 pieces of everything, right? And that's a pain in the butt. And here he's proposing to figure out an automated solution for this. And I know we featured his bolt spitter machine before. This is the next step. He's taking these, I guess they're technically screws, taking the screws out of the screw spitter machine and trying to convey them somewhere else. He's doing this by using vinyl tubing, but he finds that they eventually kind of get stuck in the tubing, and especially if you want to move them sideways, you don't have gravity to rely on. So he's going to use a compressed air assist to like scoot them on through the tubing, and he makes this really nice little 3D printed Y kind of mechanism that you can, you know, put a solenoid valve, compressed air in here, and it just spits them out. And that's so sweet. And, you know, of course, the video starts off with a money shot of him spitting screws out of this vinyl tube. It's absolutely lovely. He then goes on to take a piece that he calls a reorienter, which it takes the screws and it flips them so that they're screw head up. He wants to merge that with the accelerator part, which is the part where the air comes in and spits in. And this is the part I thought was kind of philosophically interesting about this piece and about the work he's doing. And he says in the video he'll talk about it more if people want to. And then if you go down in the YouTube comments, everybody wants to hear more about this. He calls it complexity shifting. Take the complicated parts and make sure all the complexity is in the 3D printed parts so that the other parts are as simple as possible. And in this case, that means merging all of the tricky widgets together. So the accelerator, the reorienter are in one big 3D printed part, and everything else is like vinyl tubing that you've zip tied onto it, or, you know, these boxes that everything fits into. I think that's a neat philosophy, but then when he applies it here, I'm also thinking, yeah, but you've taken kind of two separate actions and you've merged them into one. And so there's some kind of nice, it's also kind of nice to have your features modular and independent of each other. So, you know, if you need more force coming out of the accelerator, you can tweak that part and you don't have to redesign the reorienter. And here he's kind of mixing those two together. And I think that's a neat kind of design philosophy trade-off that he's getting into. And I want to see how this develops. I don't know. What do you think? Put all the complexity in the 3D printed parts or try to work your way around it elsewhere?
I mean, I like the idea of putting the complexity in the parts because, it is so much easier to modify and kind of iterate through the printed parts, right? Much more so than, well, first of all, metal.
Right. Anything that requires a hacksaw.
Right. Like, you don't have, most of us anyway, don't have the ability to kind of do these complicated things in anything but plastic at home right now. So I think there certainly is value in like you're saying, get what you can off the shelf, get the 2020 extrusion and your bolts and that kind of stuff, but the actual working pieces, you can print out and okay, that doesn't work, let me tweak this, let me move this over, a half a millimeter or something, and just keep running them off. And I think that is kind of the beauty of, especially the as desktop 3D printers have gotten more accurate and faster and more reliable, that you can kind of crank these things out and keep evolving until you get to where you're trying to go. And it's certainly got a very impressive looking setup. If you haven't watched the video, you should definitely check it out. I love how they all fit in like milk crates, and then he can like stack them up, which seems like so brilliant. It never occurred to me, like, who would have thought milk crates would be like a key component in this like automated assembly system. But it seems like every machine is built so that it fits into a milk crate, and then the milk crates, if you've never stacked milk crates before, they automatically like center themselves. They have these little ridges and stuff. So it's very impressive. Like I said, I like that he's using the printed parts for the complexity, and I also like that it's not like one big machine that does everything too. He's got these little, like you said, there's the reorienting one and there's the little booster one or whatever. I think you could fall down this pitfall where you try to make one device that does everything at once. Whereas his approach, what seems to be, you get one thing working perfectly. You get the screws flipping perfectly 100% of the time. So, okay, boom, that's done. What's the next on the list? Okay, now how do we get them to go through the tube? And you kind of approach it modularly, like that. And I think that kind of takes a lot of the. I know for me, when I'm looking at a project or something, taking the totality sometimes is overwhelming, right? Like, how can I, how am I going to get to the end, right? The end just seems too far away. But if you kind of break it down into these smaller goals, like these smaller milestones, I find that personally does help me a lot. So, I mean, that could be sort of where he's coming from too.
You will be not at all surprised to know that those are not actually milk crates. Those are
printed milk crates?
No, they're Euro containers.
Oh,
and this is like one of the Germanest possible things. We have these boxes in fixed sizes. So they come in like absolutely standard sizes and they all fit together and it's really fantastic. And so they come in like 30 by 20 or 40 by 30 or 60 by 40. So you can stack them sideways on each other too. It's this whole like system of boxes. And I'm actually looking it up on Wikipedia right now. And they say that the Eurobox system came out of the German Automotive Association. And these boxes were originally designed to streamline automotive parts and, automotive manufacturing. But they're super common and they're like in all the hardware stores here. And like half of my closet is fixed up with them now.
I did think they were rather sexy looking for milk crates because like here in the States, milk crates are always dirty and been kicked around, right? And probably because you stole them from the side of the road too. These look remarkably new in uniform, so that's pretty cool.
Yeah, well, you have to buy them. You also have to pay to play. They're not cheap. They're really fantastic, but they pull some money out of your pocket for them too. Random tidbit.
Well, so one of my things, and I know I've talked about this before, is when you're designing for 3D printed stuff, it's easy to get kind of stuck in like the traditional mindset. Everything's right angles and everything's, as if you're building with wood or something that you had to cut by hand.
Yeah.
But you don't need to. If you can really embrace the capabilities of the printer, your end result is going to be all the better. And this is definitely what he's doing. I mean, this is like 3D print first. Like you can tell, like from the like embedded zip tie things to tighten the hoses, which is just like trust me. By the way, like do that. Like if you're ever designing 3D printed stuff, put little holes in them to run zip ties through. Because once you start doing that, it is a game changer. Because it's so easy to just print that little void, and it makes it super convenient way to attach things. But yeah, I mean, this is really got a fantastic vision for like how to make 3D printed stuff, and that's really cool to see. And I love it.
He's got part numbers with revision codes printed on the side of them, and that's actually a trick I learned from Joshua Vasquez, who's doing that with his Jubilee 3D printer. He writes for us every once in a while. I'll dig that article up for you. It's really great. He talks about the virtues of, putting your versioning information, and I think he even just uses the GitHub hash, the GitHub commit hash, and he like prints that into the object. So you can always tell which version of the part you've got. And that's just brilliant.
And like I was saying before, if you're constantly evolving and you'll have all these new versions, pretty soon you're gonna be like, well, damn it, is that version 3 of the thing, or am I on version 4, am I on version 5? I mean, so it makes perfect sense. I mean, it is like I said, it just, the whole thing really grabs the capability of desktop 3D printing by the horns, and it's just really cool to see. Well, from one 3D printed contraption into another, this article is actually one of mine that I wrote, so it's kind of like cheating. This is about the Cocoa Press chocolate 3D printer that is now officially available for pre-order as a kit. And cool thing with this is that this is a project that Hackaday has been following for a long time now. For the first time we saw the Cocoa Press was in 2018 at New York Maker Faire, and at the time it was, I mean, I came away impressed because I wrote up an article about it, right? So it wasn't impressive. It was an impressive machine, but it was very complicated and it was very big, and it was, I would say, hard at the time. It was hard to imagine that it would ever be practical, right? Mm-hmm. Just from the size of it and the complexity. And I mean, there's a picture of it in the article. You can go back to read the 2018 one. I mean, there's tubes everywhere and all kinds of valves and solenoids. It was it was brilliant, but it was a little bit crazy too. Fast forward, I think it was like 2019 or 2020, like before the pandemic. I was at the Philadelphia Maker Faire and I saw it again, but this time it was much smaller and much more sleek, and the plywood had given way to like a metal frame, and you didn't see all this exposed stuff. And I was like, okay, yeah, clearly there's progress being made, right? Like they're turning this to something that you could actually see, if not in the home kitchen, right? At least in a big restaurant kitchen or something like that, you know. I was like, okay, great. You know, they got there, and then not that long ago, I saw that Ellie Weinstein, the creator, she had announced that, hey, we're finally getting ready to hit market, and kind of a little bit surprising to me is instead of it being this turnkey thing, it's going to be a DIY kit you build, which, of course, is right up our our alley. And this final kit is even smaller than the last time I saw it in 2019. It's actually, at this point, it's based on the Voron printer with just the kind of the chocolate extruder mounted to the top. It's remarkably small in the grand scheme of things. I don't think it's any bigger than your usual desktop machine now, other than the towering chocolate extruder on the top. And, part of that is it has a lot of the complexity that I saw in the original 2018 version has gone away, which I don't think is bad. I think it didn't need to be so complex. I remember one of the things I saw in 2018 was that it was using compressed air to push the chocolate through the syringe and extrude it. And the idea was, well, since you're using compressed air, there's no plunger, you don't have to clean it, and yada yada. And I thought, okay, that's cool, but there's a lot involved in doing compressed air, right? You got to have a compressor and a tank and little valves and all that stuff. In the end, this final version just goes to a plunger spun with a stepper motor. So like stuff like that, where I think that they were cool ideas. They don't necessarily lend themselves to mass production. It's just been really cool to see this evolve over time from this monstrous machine to something very, very sleek, and I'm curious to see what people do with it and when it gets in their hands. It is marketed obviously as a chocolate 3D printer, right? But we've seen the concept of extruding a paste can be used for all kinds of edible stuff. So I'm sure people will experiment with other things, frosting and that kind of stuff. So I'm really curious to see what people do with it. It's supposed to start shipping by the end of the year, I believe, and it's just really cool to see the project evolve. And it's always cool, I think, to see someone's personal projects turn into a commercial venture. And we've been fortunate enough to see that happen a few times on Hackaday, like stuff that we covered early on and then become, I always think of like the Ardu Boy and stuff like that, where, it was just some guy's idea. Oh, hey, I'll make a little business card that plays games. And then now you can go online and buy an Ardu Boy, and it's a huge thing. And it had a very humble beginning. And with luck, this will be the, same kind of story for chocolate 3D printing.
I love this one because chocolate is such a weird engineering material. And this, this just tackles that head on. The goal is to get all of the chocolate in this relatively large piston, basically, all at the same temperature, which is kind of just melting. And that's also kind of neat because chocolate is like that. Chocolate really does have kind of a melting, solidifying temperature, and it's a pretty tight gradient. So you actually could get away with something like making a chocolate 3D printer. And of course, I'm not just talking theory here. She's done it. But I love the idea of getting it to like just melt this whole volume of it. And then as it cools off, it solidifies up. Oh man, I'm looking so forward to the future where like my son, instead of getting to lick the spoon after we make cookies, he's like, can I eat the support material? My next hack comes from Adrian Kingsley Hughes. Cheap deburring tool is a game changer for 3D printing. Man, the 3D printing pylon continues. If you haven't seen one of these like deburring tools, I think I've used them mostly in the context of cleaning up the insides of pipes after you cut a pipe. Oh, it's kind of got a swivelly blade on the head, and it's in a handle, and you just stick it in the part you want to deburr, and you go swidgy, and it takes them off. Here, he's suggesting using it for 3D prints, and I've been doing this for a million years now. I actually have two. I have one in the shop downstairs that I use for metal, and one up here that I use for 3D prints. And if your first layer is a little bit too squished, you always want to cut that extra little lip off. And what is the perfect tool to do that? A deburring tool. So go get yourself one if you don't have one. My God, I totally agree with him. This is the best thing ever. my God, my son got a unicycle. The seat post was too tall. So we're like, oh, we'll just take it down to the shop and cut it. And of course, we're deburring it with the deburring tool too. But this was, on stainless steel. You need a deburring tool. You probably need two. They're really great. Oh, I also use them for cleaning out the inside of holes. You know how 3D prints always end up with the hole a little bit too tight sometimes? And sometimes if you're lucky, it's just at the top layer or the bottom layer. Deburring tool in, zip, 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 and, all of a sudden your screws fit again. They're just wonderful. But this made me think about this kind of general topic of, the funny, crazy little hacks that make your 3D printing life easier. And the other one that came to mind was using a hairdryer or a heat gun to get rid of the stringing. You don't want to take that string off by hand. You can just hit it with a hairdryer. And I've even heard some people propose to use that for smoothing prints a little bit, but I'm always scared of melting them too much. What do you got? What's your crazy out of the blue tool pick for 3D printing?
I have to admit, I do not have a deburring tool, and
Ooh.
I feel like I must. I mean, I think that is the takeaway, right? And they are like they're super cheap, and I was aware of them, right? Like I've seen people use them on videos and stuff, and it always those things are like, oh, I gotta order one of them. Next time I think about it, I gotta order them because I am guilty of using a little X-Acto knife to clean up. If you got especially with I notice with PETG, it tends to string a little bit if you're jumping between pieces, and if you have multiple pieces on the bed and where the head moves from one to the other, you always kind of have that like the little bit of wispiness. So I use the knife there. I have also used though a little torch, and that helps too with the stringiness. Especially for a while, I was printing little miniature ships for this game, the board game, and between like the funnels on the, you're only talking about make like a 5mm distance between the two of them, so there was a relatively small gap, and the strings would build up because there wasn't a lot of time, I guess, for it to cool off or whatever. But if you hit it real quick with the torch, they just kind of like, it's magic. They just disappear because they kind of they're so thin they vaporize. But of course, like you said, you don't want to go too far with the torch because you have precious little time between vaporizing strings and a puddle of plastic on the bench. It's good to have like a thin tool to get stuff off the bed. Of course, that was kind of predating like magnetic spring steel beds that flex, and you don't really need to like pry stuff off anymore, hopefully. So it's kind of cool to see how some of these recommendations have changed as like the state of the art for printing has changed.
Yeah, you wrote up a good piece, actually. I'll find the links for this in the show notes about what glues to use with 3D printed parts. And that was actually tremendously helpful to me. Like, I've always had trouble with super glue not being exactly what I want, but then you were like, there was this, a gel super glue essentially that actually works really damn well.
I had imagined that as like a series of posts. We always have these plans that don't necessarily.
Yeah, right.
The idea was stuff that you could find local. I think it's even called like locally sourced or something.
Exactly.
Because like there's all kinds of crazy stuff online you can get, but then you're sitting there waiting days or whatever. And it was kind of a challenge to like, hey, can I just go into the big box home improvement store and using the stuff they have there? What's worth? That might be kind of cool to look at that again too. Like what kind of little hand tools and stuff are worth grabbing for 3D printing or just general making in general. But yeah, the glue one was cool. I put together a little test rig and pulled them apart. And yeah, if anyone's out there listening, is like super glue is not great. It's easy and it's cheap and it's everywhere, and you can technically glue parts together with it, but it gives way pretty early. There are better things out there that you don't have to necessarily go to some 3D printing website to get. You can go to the store and try other stuff.
Oh, I just thought of another one. I actually have one of those little hand drills, just with like an egg beater hand drill and a set of drill bits that I keep up here because it's just so much nicer to print the holes a little bit small and then drill them out to size, because you get A, the holes are the perfect size, and B, you just don't have to worry about any of those funny things that can make them undersized when you do it. So that's a trick. I've seen a lot of people use those like push drills, the like pin drills, to do the same thing, and that might be a cool addition too. I just happen to have a spare egg beater drill flying around.
Well, for that matter, I have a cheap like a Harbor Freight tap set too.
Oh yeah, totally.
They're so crap. I don't know if I'd try to actually tap metal with them, but they can certainly tap a hole in PLA. And like you said, you just add more perimeters around the hole, so you got some meat to work with. And the downside is you probably don't need all the sizes, right? You really just need like a M3, M4, M5 probably would be enough for most of it. But I'm not tapping 12 metric holes and things, but run the tap through it real quick, and you get a nice threaded hole, much more finely than you could print. I mean, it was a big enough thread you could print it, but not for M2 or M3 or something like that. I think we're working on a whole new article here now,
That's
right?
a good one. Yeah, when I'm feeling saucy, I just drive the screw in there and don't worry about it. But
I've even seen people heat up a screw, like hit the screw with a torch or something, and then run the screw in real fast, so that it actually melts its own threads. Nice. And then let it cool, and then when you spin it back out, in theory you'll have threads. I mean that's there you go. That's another one.
There's a series or an Ask Hackaday or something here.
We got to do like the force required to pull them out, right? You do one that's tapped, one that's made its own threads. You do a heat insert.
Yeah.
Of course, I'm sure some YouTube person's already done it. We've probably written about it too. Now that I think about it. Now, I was going to say this last one has nothing to do with 3D printing, but now that I think about it, you might also use this for your 3D printer. But this is using an old smartphone in place of a Raspberry Pi. I don't think I have to tell anybody listening to this that the Raspberry Pis are a little hard to come by these days, or at least at reasonable prices. It just so happens that there are little single-board Linux computers that you can get for a song, and they come with screens, and they come with speakers and buttons and Wi-Fi and everything you could ask for, and they're called phones. And they're called the millions and millions of Android smartphones that get put in drawers because they're replaced with the latest and greatest. Now, is it as easy as popping an SD card into a Pi and booting into your standard Linux environment? No, unfortunately not. I mean, we'd love that. I think that would be great. I think we could all agree that if you could just repurpose a smartphone as a proper Linux computer, things would be a lot better from like an e-waste standpoint and that kind of thing. But we're not quite there yet. This post here kind of goes over where we are. Author David, he starts with like the stock firmware on a Samsung phone. It goes predictably poorly. The stock firmware is trying to do stuff like optimize for battery usage and whatever. So it keeps like killing the processes and that sort of thing. Plus, trying to get root on some of these stock firmwares is tricky, and you got locked bootloaders to contend with. The next step would be to try something like Lineage OS, which is still Android, but it is community developed and is a lot more configurable, a lot more relaxed in what you can do. Obviously, not every device is going to be supported by Lineage OS, but if you do go, and I actually checked the site right before we recorded this, I was impressed how many devices they do support now. I think the last time I looked into it was pretty narrow range of devices they supported, but now there's some pretty impressive. Actually, there's several that I own, several devices that I have sitting in a box that would now work with Lineage OS, and I think that might be something to explore. Maybe that'd be cool to do an article on installing it and seeing what you can do. Put Lineage OS on there, then you can get a terminal emulator. You can tap into Android is, and this is going to probably upset some people out there. Android is effectively just a Linux distribution, so it has a lot of the same tools running under the hood. You just never interact with them. So if you download a terminal emulator, you can find yourself in a remarkably familiar environment very quickly. In fact, a lot of stuff, if it's a lot of programs, a lot of like Python scripts, they'll run copied right off your desktop. You can, run them right onto the phone. And then some other people talked about Postmarket OS, which is a proper Linux distribution, where you talk about literally like a mobile Linux. You take away that kind of Android abstraction. That's probably the best bet, but few devices can run Postmarket OS, and that's not knocking the project. They really got the deck is stacked against them. You have to getting devices that will let you run like a stock Linux kernel on them is not an easy job. So far fewer devices that can run Postmarket OS, but if you do have one that can handle it, that is going to give you the closest Linux single board experience like you'd get on the Pi. I guess long story short here is it's not as easy as we'd like. We'd love to be able to just put a firmware image on an SD card, stick it in the side, and have a device we completely own. Unfortunately, that's not exactly the case, but increasingly there are options to turn your old phone into something more than a dust magnet.
Yeah, I want to get post-market OS running on something, and I never have, because it would be cool to just turn it into a simple Linux box. But the next best solution, I think, is all of these, like this project, or like the Octoprint server on a phone is pretty good. I always want to use cell phones for what they're not good at, which is like interfacing with real-time things, like, as a robot brain or drive motors. Then you have all this interfacing question. But if you just want to run it as a music server on your home network, that's just software and networking. Like, that's the easy stuff. And if you want to run it as an Octoprint server, pretty much ditto. So like there's all these ways where people use, Raspberry Pi or whatever small computer around as essentially, just a small server, that using a cell phone should actually be a pretty easy solution for. I mean, that's what I kind of got as the take home in this project is, you want a music server, boom, old cell phone, done. That's something that it should be good at. Serving, a couple random web pages. I wonder if it wouldn't make a good, kind of central computer for a home automation network.
Oh, yeah.
If everything's Wi-Fi anyway, there you go.
Like this post did kind of focus on how to get a more Linuxy, up to getting a proper Linux, environment on there. But there are a lot of just regular Android apps, too, that can accomplish a lot of these things. Like you're saying, I'm positive there are native Android web server apps that you could just install. And you don't need to try to shoehorn Apache onto your phone if you're just trying to, show a couple websites. And we've seen all kinds of... I know there's apps to... We've covered some of them where like you can use the phone as an IP camera and that kind of stuff. So that's also a route to explore. It's possible whatever you're trying to do can be done just already with just you go into the app store and grabbing a pre-made thing. And of course, there's also, for those not aware, there's like F-Droid, which is a secondary or alternate app store that's all open source apps, which I know you don't necessarily want to put your primary Google credentials onto an old phone that's strapped up to the wall working as a as a security camera, right? If you wanted to, you can put the F-Droid app store on the phone without any kind of credentials. You don't have to log into the, whereas usually to get into Google Play Store, I'd want you to log in or whatever. You could just, sideload F-Droid on there and then go through those apps. So there are options where you don't even really need to hack the phone, realistically. You can just kind of install an app and away you go.
Ironically, my tinfoil hat has so many layers that I wouldn't install anything but F-Droid on the phone that's my daily driver, because that's the one I'm carrying around with me. Like, I do have Google Play installed on the phone that I use primarily as an alarm clock, because it's always sitting there in my bedroom and I just don't give it a shot at. But if it was a phone I was actually using and actually carrying around with me, no Google crap on it for me, man.
Well, fair enough, and I'm not gonna disagree with you
F-Droid all the way.
But like if you had some phone and you're like, hey, maybe you got it from a flea market or something. Who knows? You just got some phone. You don't want to log into it. You could sideload F-Droid. You could download a terminal emulator from there, you could have a little handheld Linux box without having to compromise any of your accounts. So just something to keep in mind. You don't have to give the machine your firstborn just to use an Android device.
And you don't have to be a total tinfoil hatter to use F-Droid either. It's actually pretty awesome.
Yeah, it's somewhere in the middle there. F-Droid is a very cool project that I think more people should be aware of.
My first quick hack this week comes from Sebastian Bilodel, Hackaday Prize 2023 entry, Explore the Basics of Neuroscience with this Electronic Neuron. This was an entry into the previous educational category, Analog Electronic Neuron. It does everything nerves do. It does the whole spiking potential stuff and shows it on a sweet LED output, and you can connect them together and see how nerves work. It's like neuroscience. It's awesome. Teaching tech recreating a non-standard USB cable. This is a sweet story of making a custom plug that no longer exists anymore. This is your reminder that taking a photo or dimensional drawing of something makes making CAD modules to fit with it much easier. Mike Kibble, op-amp challenge entry, what's your monitor's delay? This is an analog op-amp to detect how quickly a photosensor responds, and then the rest of it is in an FPGA. It's creating a DVI, digital video signal, displays it on the monitor, and then figures out how long it takes for that to eventually be displayed on the monitor using the photosensor. He can measure response times, figures out that he's got about a 30 millisecond delay and about a 4.2 millisecond refresh rate, exactly as it was advertised to have. Whether a 30 millisecond delay is too much for you depends on whether you're a better gamer than I am. And last up, Paul Prog, the cheap and available microwave playground. This is the beginnings of experimenting with using LNBs. These are the microwave satellite dish receiver amplifiers that are normally used as receivers. Here he is taking it, using the local oscillator on it to actually generate microwave signals, and basically just looking into hacking LNBs to do radio experimentation in the kind of 12 to 18 gigahertz range. If you're into dorking around with microwaves, this might be a way to get your foot in the door on the cheap.
My first quick hack is LED matrix displays get new look thanks to SMD stencils. This is a really, really cool hack, and I mean it is a hack, like in the purest definition of hack. Upier realized that we have this cheap PCB production, and now we have cheap SMD stencil production for it. I could just send away for a thin piece of metal with a bunch of tiny little designs etched into it and put that on top of an LED matrix, and wouldn't you know, it looks phenomenal. I mean, he experiments here with a couple different shapes, from squares to triangles to something that looks like a flux capacitor. I don't know what its official name is, like kind of like a Y shape. It really, really brings to life that, we've all seen like this little square LED matrix or the round ones. I mean, this really makes it look very unique, and he's actually coupled that with a smoked plastic sheet, which brings the contrast up, and it just, on a purely aesthetic standpoint, if you're looking to make your LED matrix much more unique and maybe trying to give it some kind of like cyberpunk vibe, this is a super cheap way to do it. Next up is an entry into the Hackaday Prize. This is tiny artsy aircraft built using foam and ESP12. Maybe some of the commenters here got a little too focused on the foam plane itself, and they're like, oh, whatever, big deal, foam planes. Like, foam planes are hardly, something new. The plane is just like a demonstrator for the ESP12 based flight controller. And even that, I say flight controller, but it's really a moving thing controller, because he talks about it also being used for boats and cars and anything that needs to move and has like differential thrust. And the idea here is to just make a very cheap and accessible remote controlled device, and to be able to use that for, STEM educational projects. Outside the ESP12, it's just like a couple passives, but really here, I mean, there's the two MOSFETs for the motor control, but ultimately it's a very simple board. And even if you look into the project, Robbie talks about like the firmware is ready to go too. Like, you don't have to like come up with your own firmware. It already has a firmware for you controlling from your phone and moving the motors. So in theory, a student could take this thing, make their own little motorized thing, slap it on, and be going for very little. So that's of course in education what you want. You want to bring the per seat cost as low as possible. And lastly is building a Wi-Fi picture frame with an e-ink display. And I know what you're gonna say. We've seen so many e-ink picture frames. How many more variations can we see? You might already have a couple in your house that you don't know what to do with. It seems like one of these projects that get more and more popular. But this one's a little different because it is made by the legendary Sprite TM. And if you don't know who Sprite TM is, go read more Hackaday, because he's been, I think his site probably predates Hackaday by a couple years, and we've always loved covering his projects. And he brings a certain level of polish and documentation to it. This is, if you're looking for the benchmark on how to do a ESP32 based e-ink picture frame, and you want to have all the details, and you want to know maybe even more than you necessarily needed to know about how it all works, this is the project to check out.
All right, it's time for our can't miss articles. These are long form pieces written by our fantastic Hackaday writing staff. This week, I want to feature Al Williams's Rising to the Occasion, a brief history of crude high altitude balloons. And so this is putting people up in high altitude balloons instead of just, a lightweight electronic payload. And it begins because lighter than air flight predates heavier than air flight, of course. People were flying up into the air into the balloons, at least as far back as the Montgolfier brothers in 1783, but probably before that as well. Who knows? The point is, as long as you can get, enough hot air in a balloon, or later hydrogen or helium in a balloon, you can go certainly higher than you can breathe most of the way up to space. Yeah, stratosphere. Higher than you want to go without taking precautions. And I think that's what's interesting about the early era of ballooning, is that people kind of discovered that the atmosphere got thinner and thinner by doing and passing out. And there's some dangerous things that happened. The reason I wanted to write this up, though, is that if you don't know about the story of Joseph Kittinger, you absolutely should check him out on, YouTube or whatever. This is the craziest thing. So flashback to 1960s. The question is, if somebody gets ejected from a jet airplane, how do you get them to parachute successfully to the ground? And this was basically the invention of what we now think of as the drogue chutes, right? So if you're going really fast, you want to put out a small parachute first to slow you down, and then a big parachute to carry you safely to the ground. They wanted to experiment with this, but they didn't want to shoot people out of fast-moving jet airplanes, because that was seen as, kind of dangerous. This is also right before people are going to space, and they wanted to experiment with different pressurized, essentially spacesuit designs. And so Joseph Kittinger, who was a test pilot and all-around super-duper badass, got sent up to over 100,000 feet, 31,000 meters, to then jump out of the thing and parachute back to Earth. And the fact that this actually happened is insane. The fact that he had a hole in one of his gloves and couldn't use his right hand and didn't call the mission off because, he'd have to do it again is like really hardcore. My favorite about this is they filmed it, and there's some footage of him jumping out. And I try to imagine myself. I became aware of this just about the time that we were putting up our first high altitude balloons at my hackerspace. And, so we were getting all these great pictures from kind of the same altitude, 100,000 feet. And it really looks like you're in space. You're not, but it really looks like you are, dark black sky, curvy Earth, the whole deal. And then there's this footage of him where he's actually jumping out of a gondola at this height. And there's just like a split second there where he actually does it. And I tried to imagine myself being up there. First of all, no, not in a million years. And second, jumping out of this thing. And it's just, to be the first person to do it ever is insane, because you do not know if you're going to live. Anyway, they, with whatever kind of sense of humor the Air Force has at the time, wrote on it, "This is the highest step in the world." And that shows up in the video too. So you can see him stepping off this ledge, and if you listen back to the footage, he was actually kind of a little bit punch drunk at the point, and they were trying to walk him through this 27-point checklist over radio to get him out of this thing. And he's a little bit woozy, and his right hand is swollen up to 2 times its normal size because he's got a leak in his spacesuit, and the fact that this whole thing works. And so if you look at the picture I picked I actually tossed the photo on this one. If you look at the headline picture I snapped out of that phenomenal footage, you could see him just after jumping out, and you could see that the back of his suit is all held together with like tape, like duct tape. What is going on here? He lands on the ground. There's a point in the film actually where his doctor hits him in the shoulder. And later he said in an interview that was when he told him that he had a hole in his pressure suit, and then didn't tell them even though he knew this was going on in the mission. And his physician actually hits him in the shoulder for not having told him, and then offers him a cigarette because
as you do, right?
That's what you did back then.
Back then, like, let's all have a good smoke. We
survived the most insane mission. It worked. Let's just light one up. He died at the ripe age of 94, actually, just last December. So R.I.P. Joseph Kittinger. But go check out the video if you haven't. It's just insane.
And he was involved too in when Baumgartner did it in 2012.
Right.
Which I thought was cool. He was like a technical advisor, and as I recall, Baumgartner had like him on an earpiece the whole way up.
Yeah.
Because like who else do you talk to except the only guy who's ever done this, And I know that they had some like words of encouragement and stuff at the peak. I do think that like you're getting the nerve to jump out. I think it does help that at some point the balloon was going to pop anyway. So either you jump out on your own terms, or you wait till that thing pops, and now you're trying to jump out of a tumbling aluminum can. So
yep,
I think that probably helped steal him. But it's kind of funny that you picked up on this one for Kittinger, because I thought it was fascinating for everybody else. Like I think Kittinger's probably fairly well. I mean, if you're into this kind of thing, but even I consider myself a fairly high caliber space nerd. And I was surprised by some of these earlier ones I had not heard about. I didn't realize that people had actually died in some of these high altitude balloon attempts in the past. I'd heard Picard, which is incidentally who they named the captain after in Next Generation. But yeah, in between them in the 30s and stuff, that it was very fascinating to read about some of these attempts, and especially the one with which one was that with the Christian Zill? That was in 1935, and said that they were descending, so he told the crew to jump out and was gonna go down with the balloon. Because he didn't want to, that's like some old school mentality. Like, I guess I'll go down with the balloon, gentlemen. Like, the hell with that. But it said that there was a parachute that he could have pulled, but he was worried that it would have destroyed the scientific instruments. I guess the shock from getting hit with the parachute. So this dude just rode it down to the ground and it climbed out on the outside. He climbed to the outside at the end, and it says in here, like, probably because he thought, like, I guess I'll be thrown clear in the impact or whatever. Long story, it came down well enough that he survived and he didn't need to be thrown clear. But like, imagine, talking about some dedication. Like, what kind of experiments could they have had on this balloon that was worth, maybe riding it down to your death for? But hey, you gotta believe in something, right? My can't miss article this week is from Christina Panos, and this is Barcodes Enter the Matrix in 2027. And it's not just because of the Joe Kim art, although it is in large part because of the Joe Kim art that has Neo flying over a barcode. But I thought this was personally very illuminating because I had no idea, and I'd wager to bet a lot of the people reading this or listening to this didn't know that the traditional barcode that has been in existence for as long as most of us have been alive is going away in 2027, as it's going to be replaced with a two-dimensional one. And the idea here is that you can convey a lot more information through there, which of course we know. I mean, you scan a QR code, you can get a link, or you can get, there's even programs that have been, we wrote an article at one time where somebody compressed a whole game into a QR code. So there's a lot of possibilities there. both negative and positive. There's a quote in the article from Kerry Wilkie, the SVP of Standards and Technology at US One, just that the 2D barcode will take you on an experience that the brand wants you to have. And I gotta tell you, I'm not interested in going on anybody's experience. I just want to buy the gallon of milk. So I'm a little concerned about like what the future is going to be looking like. But I do think that it's easy for me to imagine a future in which we just check out at the store with our phones. I think that's probably long term where a lot of this is going. That there's not going to be. I mean, I used to always still have the register, right? But you go now, self checkout is the norm, and I think the next step is probably we're just going to have. You'll have the app from your grocery store on your phone, and you just scan the stuff in your cart, and you pay that way. And I think that's probably where they're thinking that if you have a future in which people are scanning with their own devices, well, let's make it a 2D barcode because then we can bring them to a website or bring them special reward points because you scanned Tide instead of the generic laundry detergent. So there is a concerning future there about like I just want to pay for it. I don't want to sign up for anything. I don't want to give you my email. Which, if you've ever bought any kind of smart device, I saw some cartoon recently. It was like, why do I have to give you my email to use a thermometer? But that's where we're at, right? Like everything's increasingly smart. And also, I like this one because it reminded me a lot of the article I did about the SIM card, in which, the SIM card is being slowly phased out for a newer technology that doesn't seem advantageous to us as the consumer, right? Like, we like SIM cards because they're easy. We like barcodes because they're easy. Why do they need to be changed? And, if you have to ask, you're probably not going to like the answer. Beyond that, in both cases, as Christina kind of found, then like when I found about writing about the SIM card, is there's a lot of interesting history behind it too. So on one hand, it is talking about this new 2D barcode and what that's going to bring to it. But then she also goes into like the history of barcodes, and they go back to the 30s. Like Westinghouse was trying to figure out a way to like sort parts and stuff. So they came up with like the precursor of what we now know as the traditional barcode. So it's just a really interesting story going forward and backwards in time, and kind of just getting you ready for the future in which like every time you scan something at the grocery store, you might be seeing some kind of ad or something even worse. Some man-made horror that I can't even imagine.
Take you on an experience that the brand wants you to have.
Yeah.
No, I'm with you, and a lot of the commenters kind of keyed onto this dystopian future part. I think somehow a lot of them expected them to be tracked by these, and I don't think they're necessarily going to be opening up web pages. I don't think it's going to be like QR codes in that sense. I think it's just going to be encoding data. And if you look at the white paper they've got, they actually do talk about two specs they're looking at for these 2D barcodes. One actually is a QR code, and the other is the data matrix, which is, it's again a bunch of blobs. It doesn't have those little targets in it. Instead, it's got an L-shaped alignment feature on the left and bottom side. They're kind of another familiar 2D barcode. And I do think what's interesting about this is the idea that you can put more information in there, like expiry dates or lot numbers or stuff like that. So, you can put more granular information there in case you need to do like a product recall or, anything like that.
Christine even mentioned in the end, apparently some places using this kind of technology already for that expiration dates, and she mentioned that there's a retailer in Japan that if you scan something that's like going to expire soon, it'll actually give you a discount. You know what I mean? So that kind of stuff is being baked into the QR code. You imagine you scan a thing of milk, and it's like, hey, by the way, this is expiring in 2 days. Are you sure you want to buy this? So I mean, there are practical things, but it's like so many other tools. It depends on who's using it and what their intent is, right?
And the other thing I was thinking of course, is how the heck to make this transition. Like all your barcode scanners in the store are now going to need to be basically cameras and handle 2D barcodes because they can't just be like laser line scanners like the usual barcode readers. And how that's going to work, I don't know. They do have interim suggestions, which include, and I don't know for how long they're suggesting we will live in this interim regime, but where you put both of them on the bag of chips that they have in the example here, right? So they have the 2D barcode right up next to the 3D barcode. And they actually are also trying to get human readable text next to the barcode. So again, it's not like there's going to be secret information on there that's like giving you away or anything. You're going to also probably be able to read the expiry date and the lot number and all that because it's going to be printed in human readable text next to it. So, I don't think this is super duper sinister. I do think it's an interesting idea to pack more automatic information, more machine readable information into the code. And man, if you think about how long the barcode has survived essentially unaltered, it's absolutely crazy. Like, how is it possible that we're still using tech from like the 50s and 60s on all of this? Like, I should have been phased out long ago. Why are we still dealing with this relic stuff? What's going on here?
If it works.
Like, even the U.S. Post Office uses a more advanced barcode than this. If you can think of an institution more conservative than the USPS, please do. And they're ahead of the game on this. So it's high time. I have no idea. I'm not as afraid of the dystopian future as some people are. I certainly don't want to be guided on any experience that a brand wants me to have either.
Yeah. But, please, sir, I just check out.
Loyalty points. Get me loyalty points.
I don't think it was mentioned here, and maybe this was something I want to say maybe Jenny brought up, and it was I thought a very astute kind of point. Is that one advantage of the one-dimensional barcode, and I've seen this in practice, is that you can extend it infinitely, and it's still readable. So, like, I know for, like, the cases of water that we get, they have a barcode that literally stretches the entire bottom of the case.
Yeah.
Because they just took the barcode, just stretched it out, and anywhere along that line, you can hit it, and it works. And you can see how for when these things are flying down a conveyor belt or something, how helpful that would be. When you're moving over to this 2D barcode, now you have to be super accurate.
Needs to be spot in the middle.
Right, you have to know exactly where it is. You got to get a good look at it. We do know it has like the error correction, and it is pretty impressive, But nothing like a barcode that's 5 foot long, and you can hit it anywhere along that length and get the same data out of it. So there's reasons that the the old school barcode has been hanging around for as long as it has, and I wonder, there must be a reason they're doing it, right? So like, what is that going to look like in a transition? How do you solve that problem? So it should be interesting, and all happening. Have we said 2027 is the date? So this is all
proposed to be happening in the next
fairly soon.
Yeah,
this is not like
years.
20, 30 years away.
Yep.
So it'll be a brave new world.
That wraps it up for this week's Hackaday podcast. Thank you very much for listening. For all the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, send us an email, tips@hackaday.com. And until next week,
keep on hacking.
Yeah, I was actually thinking the same thing. I'm like, poor Tom always gets the sound.
All right, let me pull it down.
Cool. I think we're set. All right, let's head to quick axe. Cripes.
People laugh at me while they're driving their cars. Wouldn't be the first time.
If you want to follow